Okay, trig functions from words. We're going to call this simple harmonic motion. So let's go. Tides. Tides have a high tide, a low tide, a higher tide, a tow lot. Did I say that right? High tide, low tide, high tide, low. Yeah, you get the point. That's a periodic function. It's periodic because periodically it gets to a high tide, and we periodically keep getting the same values for our function. Simple harmonic motion can be modelled by periodic functions. How about a pendulum? A pendulum swinging backwards and forwards. How about someone on a swing, swinging forwards and backwards. We've got to get this right because by grade 12 we're going to be talking about the same situation, but I'm going to say right here, how fast is the girl going? What's her maximum speed? What's her velocity? What's her acceleration? Anyway, so we're starting here and then having more fun in grade 12. So swings, tides, temperatures, a spring bouncing, someone bouncing on a spring, oscillating, going up and down. What's their height? A porpoise jumping through the water. Some sort of spring oscillating backwards and forwards. These are all things called simple harmonic motion, and they can be modelled by periodic functions, which is what we're doing. Temperature was one that we talked about before, because the temperature can be hot, can be cold, can be hot, can be cold, can be hot through the day and through as days go on. So here we go. Here is one, words. There's a local temperature and definitely can be modelled by simple harmonic motion. You do understand that it actually isn't modelled by simple harmonic motion, but we're just in high school now, so let's just pretend that it does. All we're told is that's its coldest and that's its hottest. So what we're thinking is it's going to be a graph. Its coldest is going to be 22 degrees. Its hottest is going to be 32 degrees. Hey, where's the middle of that? Is that 27? I think that's 27. So there's my middle. Now we're going to set this as 0 time, because this is my time axis and this is my temperature axis. So we've got two T's happening, but that's okay. We might just deal with that as Y and X to not get too confused. So when we're here at 1 o'clock in the morning, it's at its minimum here, and then it's going to go up and then down, and then that is a nasty looking graph. But anyway, you get the point. There is my 32, and that happens at 1300, or let's just go 13. T is 13. I reckon that if I just stood back, that's a cos graph, and it's a special one. It's a negative cos graph. So my starting point is going to be to call it y equals negative a cos b x plus c plus d. Okay. Amplitude. How far is my up and down? I'm going up 5, down 5, because that's 10. So it's going to be y equals minus 5 cos. Centre of motion, D, 27. Like that one. B for Barry. Time period. Well, how far is it from the bottom to the top? I'm going to say that's 12. So from the bottom to the top to the bottom again must be. That's an assumption. So we're going to assume that T equals 24. B equals 2 pi on T. So that will be pi on 12. Now, let's get rid of some of this stuff. You can go back to that, I'm sure, if you needed to. Let's just, can't get rid of it all. Oh gosh, that did well. I'll go back to this red because it stands out. Now a cos graph usually starts there and goes up, but this one isn't. It's starting there and going up. So this distance here is my phase shift, and you can see that it's shifted 1 unit to the right. So that is definitely not going to be a plus. It's going to be a minus because I'm moving to the right, and I'm moving to the right 1 unit. So all of a sudden, I really haven't done a whole heap of maths, but my understanding of how that graph works, I've drawn a sketch. I've got very little information here, but I've drawn a sketch, I've interpreted the sketch, I've made some assumptions, and I've got a function. There's my red pen. Excellent. Do you think that would be the end of the question? Let's go with no. I wish I could copy paste that, but I don't think I can. See if I can remember it. Y equals minus 5 cos. I'll write that down there because we've got more to come. Now, what would happen, do you think, if for some reason you started with y equals a sine? You know what? That is a-okay. What's going to happen is you are going to get a different phase shift to marry that curve to the right position. So long as you do it right, it will work out. Here are some other ones that are exactly the same function. So we've got 5 sine. That is the same function. So I think that should be a task for you. Look at that and get into Desmos and verify that they're the same. See if you can get both answers. See if you can work it out. How about, what if you said it was a minus sine graph for some reason? Guess what? That blue one is correct too. So no problem if you get the wrong starting point. So long as you work out your phase shift properly, you're going to get the right answer. No problem at all. But anyway, let's stick with the simplest one, the one that was sort of marries in best. We all know that I get cranky when it's hot. So we're going to work out when the air conditioner goes on, because I've got it set for 29.5 degrees. Clearly that's a lie. It goes on the minute I get to work. But anyway, so we're going to set the temperature to 29.5, and we need to work out what that T is, or the X. So we're going to do this in one step. That cos pi x on 12 minus pi on 12. Let's just simplify that bracket. Let's get the 29.5, subtract 27, and then divide by minus 5. We're big boys and girls, we should be able to do that in one foul swoop. And we get minus a half. Oh my gosh, it's like I've engineered it because you are going, that's an exact value triangle. Cos of what is negative a half? Let's do it quickly. A half. 1, 2, root 3. Cos is a on h, so that's my adjacent side. So we must be talking about pi on 3. We're drawing pi on 3 where cos is negative. So that's going to be down there and down there. It's cos pi on 3. So see this bracket? Pi x on 12 minus pi on 12 could equal that. What's that? 2 pi on 3. It could equal that. That would be 4 pi on 3. I could keep going. What's that? That would be 8 pi on 3, etc., etc., etc. But I think we all know that what we're looking for is, where's 29.5? We're looking for that time and that time. Because when it's hotter than that, that's when my air conditioner's on. So I'm wanting to find that x there and that x there. So you've always got to come back to that graph and work out what you're looking for. So we won't need these infinite solutions, but, who knows? Okay, so each one of these is its own answer. So I need to get that and add pi on 12. I need to get that and add pi on 12. I need to get that and add pi on 12. I do it in your calculator if you need to. It's just fractions. If it's a no calculator exam, there should be time there for you to do that. Pretty sure you're going to get 9 pi on... I'm going to leave them in 12ths. Etc., etc. I've left them in 12s because you can see if I multiply everything by 12, they go, and I can also divide everything by pi, and my answer, x, which is my time, is either going to be 9, 17, 33, etc., etc. What do you think that 9 represents? 9 a.m. in the morning. The 17 is 5 p.m. This 33 is actually 33 hours from midnight, which is 9 a.m. the next day. And then this solution would be 5 p.m. the next day. So this could be Monday, this could be Tuesday, etc., etc. Okay, how much fun was that? Really important, you can interpret words, sketch a graph, get a function, any function that's correct is fine, and then be able to provide some solution with the potential for multiple solutions and choosing which solutions are appropriate. Okay, do some practice. That is a ripper question. Love it.